Hi, Bob. How are you?
Hey Jim, how are you doing?
Very good. Let's talk about polished concrete testing devices and why do you test?
Sounds great. Let's do it. So it's funny, Jim. In a past episode, I mentioned that I've been polishing since 1998. Like again, shows my age. That's a long time ago. But back then, we really didn't have a lot of resources at our fingertips. We'd simply go out with, a particular diamond tool and thinking that we're going to conquer the world, and only to find out that, wow, what just happened? We burned out a set of diamonds in 500 square feet, or we exposed aggregate, and there's not supposed to be, aggregate. Or perhaps you got phenolic resin burn on the joints. So there's all of these circumstances that occur. And it's been fun for me to watch how the industry has evolved since back then in 1998. One of the things as a starting point we always like to do is we do what's called a Mohs surface scratch test, Mohs hardness test. And this was derived from the mineral and aggregates side of the industry. And basically, the hardest mineral produced known to man is a diamond, which is like 9 or 10 on the Mohs scale. And then conversely, if you were to scratch talc, and some calcites, they're much softer, scratching down around 1 or 2. So traditional concrete that's got a good mix design, that's been properly placed, finished, and cured is generally going to scratch somewhere around between, say, 6 to 8, depending on the mix design and the aggregates. What we do is we put in our concrete specifications that that surface should have a minimum Mohs hardness of 5.5 to be considered a sustainable surface. But also, what I want to know is I want to know how hard or soft that surface is, because that's going to determine the bond of diamond that I use relative to the hardness of the floor. Super important that you're using the right bond of diamond relative to the surface hardness. So it's unfortunate. We've had a lot of change in our industry, and there's a lot of cement replacements that's occurring, and a lot of great unknowns. And I've been getting a lot of phone calls as of late from contractors that they start aggressive grinding, perhaps with an 80 grit metal to expose some sand, only to find out that they're experiencing delamination. And although there are some ASTM standards for testing for delamination, this is one of them, actually. This is, I think it's ASTM 4260, if I recall. This is a chain drag, and chain dragging across the surface that's been delaminated. It'll have a different tone. It'll sound almost hollow. And oftentimes it's usually as a result of premature finishing, or it could be mixed designs. Interior power child concrete slabs should not have an air entraining admixture in the mix design. And oftentimes there are some different mid-range or high-range water reducers that will actually entrain air. Or if they use a combination of admixtures in the mix, you could get higher air. So those are usually the culprits. But the remedy is to find the delamination, and then you go on from there.
So when you hear that different sound and you're feeling delamination, that's because the top layer is loose and not even attached or barely attached to underneath, right?
Yeah, you're exactly right. So, and that delamination could be as thin as 1/16 of an inch, and I've seen it all the way down to a ½ inch deep, if you can believe it. And as a consultant, you really have to take into consideration what's in the best interest of the project and your client that you're working for. Because if it's pedestrian traffic and you have only very, very light delamination, and you're not going to have heavy pallets and forklifts, it might be considered sustainable. But conversely, if it's a warehouse floor where they're, have 100 forklifts in there with thousands of pounds of weight, and you'll learn how to determine the thickness of the delamination, or I should say the depth. And it's speculatory at this point when you're just doing chain dragging like you see here. The real way to find out is conduct what's called petrography testing. And that's where you would core drill the slab, the entire depth of the concrete, and you would send it to a petrographer, which, for lack of a better terms, is a concrete scientist. And they can look at it under a microscope, and they can tell us, number one, what is the depth of the delamination, and number two, what the potential culprit of the delamination was.
Bob, I think this tool goes back so far. I saw it in Game of Thrones season 2.
Exactly. Now that's the tool previously. That's good for small areas, but if you're checking, 500,000 square feet, I'll typically use an 8-foot chain like this because I can swing it to the right and swing it to the left. And in essence, I'm covering almost 16 feet of surface area. That other one takes a little bit of time. Once you've found it, you got to hone in on it. Like I'll drag it across the surface like you see here, but then when I get close and I identify the general region of the delamination, I'll pick the chain straight up in the air, and then I'll kind of like bounce it up and down, and I'll kind of I'll identify where I feel the perimeter of the delamination is, and then of course you immediately mark it and you identify it. Oftentimes too, we'll take a floor plan, a fixture plan, or a foundation plan that shows the contraction and construction joints and the column lines. And that way you can mark it on that as well. And I mean, I've been involved, unfortunately, on some where, we're talking thousands and thousands of delaminations.
Wow.
So we talked about the depth of the delamination, and this is a close-up view of the delamination. I just mentioned at the beginning of our video here that I had a phone call from a contractor friend of mine on a recent project. They went down, it was a store down in Florida, and a store that should have taken them 8 days to grind and polish ended up taking them 1 month because they found all kinds of surface delamination. And they said they're going to pull off the job, and the contractor said, no, we don't have time. And they had them grind through all of the delamination down to the large aggregate. And so it tripled the time frame in which they should have been done. And of course, there's a huge expense to that. If you're trying to obtain a Class B salt and pepper finish versus a Class C exposed aggregate, and you're removing upwards of a 1/4 inch of material, that's very time consuming and laborious.
Oh boy.
Yeah. So now here's an interesting thing. We found delamination on a project, and you could see the surface profile here. That was from shaving. They use a concrete shaver, but that doesn't necessarily mean just because they've shaved off a 1/4 inch that they've got rid of the delamination. So once you've done the shaving or scarifying or grinding with aggressive diamonds, whatever your prep methods consist of, clean the surface and then go back and then re-chain drag the floor, assuming you're using a chain. Now there are other devices, specific specialty sounding devices, which are effective really for smaller jobs. Personally, I've found that the chain is by far the best method for me, but once the surface has already been profiled, re-chain drag it to make sure you don't hear any additional delamination. So this is what's referred to as a profilometer, and the industry refers to a profilometer as an RA meter. RA stands for roughness average. And if you look at the top components, that's what we use. We don't use too many of the other readings that are listed below that. So we hone in on the roughness average. So if I was to take this roughness average meter and put it on a piece of tempered glass, the RA would be 0, meaning there's no surface profile to it. However, if I put it on a surface that I've ground, say with 80 grit and metal bond diamonds, that roughness average might be 250. And I'm just using a fictitious number. Theoretically, if I have an RA of 250 and I'm using 80 grit metal bond diamond tool, those numbers incrementally should be decreasing if the diamond tooling is doing what it's supposed to be doing, which is cutting the floor. So if I started with an 80 and I went to a 150 metal, right? And my RA reading at 80 grit was 250. After I'm done with 150 metals, that should cut in half, okay? So half of 250 would be 125. And so my next grit, which is finer, those increments should be making dramatic decreases going towards that tempered plexiglass or glass of an RA of 0. So are you going to get an RA of 0 on concrete? No. But can you get an RA, reading below 10 or even below 5? Yes, you can, but it's going to require grout coating. Now, another reason that the RA meter is used, other than polished concrete, there are clients, national accounts that have robotics, and there has to be a very specific roughness average for the wheels of the robots. It can't be too fine or they'll just spin, and it can't be too rough because the wheels will wear out very, very fast. So the roughness average is not only just used for polishing projects, but it's also used for robotics and for other scenarios. This was derived from the automotive industry. They would use the roughness average meter is where it was derived from. So here you can see I'm holding the roughness average meter up, and you see a little stylus probe. And that probe is what drags across the surface of the concrete. It's very, very fine, and it can be subjective. You absolutely have to have a clean surface for that little probe to go back up and then back down when it goes across the concrete, and then it'll give you the digital reading. And then of course you capture that and then record that reading. That's a top view. So on the left, you can see that I'm actually taking a reading, right? I mean, I literally hit start, and the reading is not complete, that little blue line. And the little valleys and the dips that you see is the profile of the concrete. So it'll go through and it'll take those readings. And in this case, the RA roughness average was a 22, okay? Which the floor is slightly pitted. And that's a good example of how a roughness average meter would be used. So way back when we first started, this is what's referred to as a gloss meter. And it only checks one thing, and that's basically 60-degree gloss. On the bottom, there's a little mirror that's at a 60-degree angle. It shoots a beam of light, bounces off that onto the floor, and it records the data that you see here. That's what we used to use to check gloss, because gloss is very subjective, Jim. So you may look at a floor and say, wow, that looks really good and it's shiny, but then the meter says otherwise. So that's actually a relatively low gloss at 24, and I round up. So if it's 25 or 25.6, I'll round up to 26. So in this case, I would have rounded up to 25 here. And that's the earlier type meters that we used to check for gloss, because we've got to have something that's not subjective, meaning, that's going to give us the accurate reading as opposed to just using your eyeball. Now we've evolved into what's referred to as the DOI meter, which stands for Distinctness of Image. And if you look on the top left, it's recording 20-degree gloss, 60-degree gloss, and 85-degree gloss. So yes, it has three little mirrors on the bottom of this thing that shoots the different angles across the floor. And then you have DOI, which stands for the Distinctness of Image. And then you have the haze. And the haze, why do we use haze readings? Oftentimes, polishers might not do a great job of refining the surface of the concrete, and they'll load the surface with guard, for example, meaning something sacrificial, and the haze will go way up. Another scenario is, especially when it's warm out in the summer, you'll get a lot of resin transfer from your diamond tooling, and the haze readings will go way, way high, meaning they've transferred resin on the floor, where you could actually take a razor blade and scratch the resin off the floor. So what we're looking for in the polishing industry is we're looking at 60-degree gloss, which is the middle. We're looking at DOI, which is the bottom left, and then we're looking at haze. Those are the three readings that we look at in the polishing community. Now, again, I had mentioned clients with robotics. We use 85-degree gloss in that case. So this is a very effective meter that it holds the polisher accountable, and it takes all subjectivity out of the readings. So it'll tell you, if like our specification, for example, might say you need a minimum 60-degree gloss of 50 and a minimum DOI of 60 and a haze below 12. So that's actually written into the specification, and the polisher has to obtain those specified requirements.
Was it hard to learn how to read the meter here, Bob?
Not really. It's pretty simple. You want to calibrate the meter. Basically, it has a little magnetic mirror that you put on the bottom. And once you learn the signals, or I should say the how you toggle the tool, it's pretty simple. You just hit calibrate and record the calibration, and make sure everything's good. Make sure that the bottom of it is nice and clean. And very important, you got to make sure, you got to be fair to the polisher too. I've seen people go out and take readings, call me up and say, hey Bob, the 60-degree gloss is it's only 30 and it's supposed to be 50. And I'm like, what's the floor look like? Well, I just barely took a little rag and I cleaned the dust off. I'm like, well, you know what? Get an auto scrubber and get a burnisher and then let it dry and check it. Guess what? Now we're getting a 60-degree gloss of 60. So
Wow.
yeah, the person that's administering the testing has to be fair and make sure that the surface of the concrete is in fact clean. Oftentimes the polisher demobilizes. The next day, there's a layer of dust and debris, from just the different trades getting out on their work.
Now, you and I and Leanne to that Outback Steakhouse we've been to, do they get mad at you when you whip out your DOI meter at dinner?
They do. They do. They're like, don't put that meter on top of our steaks. So this, it's been fun to watch the evolution of our industry, as I had mentioned on several occasions. This is a little cart basically that Runyon Supply has come up with, and this holds both the DOI meter and the RA meter. The cool thing about it is it Bluetooths to your phone, so you get an instant report right to your phone. When you think about the old guys, like what I would do is I would take my readings, mark it on the floor plan, and and then you got to take that data and go back to your office and transfer it from a handwritten floor plan onto a PDF. That takes hours and hours and hours. Where this little guy literally is a game changer, because if you think about it, on one store you might be taking 1 to 200 readings. That means without this cart, you're going to a spot, you're bending over, you're putting your meters down, you're pushing the toggle, and then you're bending over, taking a picture. Then you're standing back 5 feet and you're taking a picture of the location. So that's a lot of strain on your body when you're doing that. Where this little device here, the DOI cart, basically is a game changer, especially because you can Bluetooth to your phone now. So you have an instant.
What a great invention.
It really is, Jim. It's been a game changer. And if all the stars are aligned and you've done all the good polishing, and you've got a low roughness average, a high gloss, a high DOI, and no haze, and that's our scenario here with my pups.
Beautiful. Thanks, Bob. Until next time.
All right, Jim. Thank you. We'll see you again.